It gets resolved. I will actually try to wake you up. Actually बाहा में suspension. अभी मैं we have meeting with dignitaries and our vice chancellor sir. So we had some small discussion. So vice chancellor sir asked us what is this BAJA actually? Whether it is BAJA or BAJA. We call it as BAJA. Obviously, it is BAJA for us, but it is BAJA. We were trying to explain him actually, but he simply said, "I understand what you will say. This was there. This was in Mexico. That. I don't understand. I will tell you what is BAJA and BAJA. If you correctly design your vehicle suspension and complete vehicle." Doesn't matter you are winning or losing this race. But if you are actually achieving your goals by correctly designing the vehicle, then it is BAJA for you. And if you are just doing formality, then it is nothing but a BAJA. Bajate raho. So please watch carefully the picture. Can anyone answer what is this? Hurdles. Very good. We see these are hurdles, and these hurdles are waiting for your vehicles eagerly because they want to break your vehicle. And these hurdles are at matrix where you will bring your vehicle for racing. And believe me, very stringent and very tough to cross them. So don't take them lightly and don't be overconfident because only your suspension and steering can overcome such hurdles easily. Now, summary of ATV operation is apparent. Like I already shown you the pictures, there would be muddy track, then rocks would be there, hills would be there, ditches would be there, potholes, mud climbing, hill climbing. There are many variable hurdles are there. So now the question comes: why we design suspension system? Can anyone answer? Apart from these two, see, I will read you for these three. Isolate chassis from vibration due to road excitations. Good handling by less changes in wheel loads for dynamic conditions. And reduce roll and pitch movements of chassis. This is regarding the BAJA vehicle and theory only and your actual road conditions. But in real life condition, why we design suspension for our on-road cars? Can anyone answer? Yes, please. Sorry. Yes, very good. Absorb the shocks. Very good. You are right. Anyone else? For the comfort and stability. Very good. So you are prepared. Nice. Actually, apart from these two major parameters are the driver comfort, driver and passenger comfort. And the vehicle should negotiate with the road unevenness. That is, he answered for shock and he answered for stability. So these are the parameters we need to take into consideration while designing our suspension system. Now, type of suspension. So first of all, what are the parameters you look for designing? You need to take into consideration, like your vehicle CG height, ground clearance, road center height and front and rear axle, motion ratios, designing of spring, damper, suspension arms, etc., sprung and unsprung mass, desired natural frequency, front and rear, both the axles, ride rates and speed rate, stiffness, suspension travels versus damper stroke. These are the parameters which will cumulatively affect your design. Now, process of suspension design. Here the job, the motto, what is the motto? The suspension shall be designed so that your vehicle, actually we need to ensure that vehicle wheels are sticking to the ground. They are not jumping uh, in a bad manner so that they can off the ground and they can topple. There should not be any rollover. So, selecting vehicle level target, selecting system architecture, choosing location of hard point, selecting rates of bushings. See, these are all critical things because these points will change as per your vehicle. Now, what is sprung and unsprung mass? I think most of you will already be aware of this. The sprung mass is which is all your suspension is holding the mass. Driver, cabin, seating, etc. And unsprung is your wheels, hubs, and your uh, lower part of the damper, steering arm, etc. So, first of all, you segregate everything on the paper and you calculate the weight. If you will calculate exact mass, unsprung and sprung, then your calculation will be starting from a, you can say, you are starting from a approach which is not going to fail. Otherwise, if you are in the beginning, if you are calculating the wrong mass, then from the beginning you will be off route. So most critical part is weight. So what you can do, full vehicle weight generally everyone takes. Every team will calculate the full vehicle weight. But you need to go part by part. Get how much deep into you can go. Because see, any one side if you will lose the 1 kg, that will make your dynamics very difficult on the road, on the track. Now, desirable targets for BAJA vehicle. These are actually targets which you should take into consideration. See, we have given you the limits in the rule book that you should fabricate, design your vehicle within some ranges. But from that ranges, you have to optimize. Like provide large wheel travel, typically 225 to 300 mm for typical ATV, ratio of jounce travel to rebound travel 2:1. Jounce and rebound. For a damper, it is a different thing. For a spring, it is a different thing. For combined damper and spring, it is a different thing. When you club double AR with that system, it is a different thing because the stiffness of double AR will take into consideration. So you need to first calculate for this jounce travel and rebound travel individual parts stiffnesses. For spring, what is for spring, what is for damper, even for tire. Because tires also have dynamic characteristics like their stiffnesses. So choose shock absorber length longer than required by 10 mm or more so that it does not bottom out with full bump. Like someone will choose a smaller damper and while hitting a bump, the force would be, see, no one can calculate the exact force while bump. We only estimate it. but our estimation should be more than actual. And you apply it, suppose for one G load is there for your vehicle, you design it for 4G. Because dynamic condition, it will not double, it will only gradually decrease. So shock absorber length is it is the critical parameter, and also the shock force. Shock force means damping force. 2x sufficient ground clearance more than 300 mm. This depends on your shock absorber length, spring length, and double AR. See, you can adjust also ground clearance. It is not a big task. You adjust your travel, suspension travel. It is adjustable. But you do not make many adjusting points, because that will make the system fragile. You will lose somewhere. Make only 2 or 3 adjustable points. I will come to that, where in which test, which hurdle you would require to adjust your suspension. Then provide sufficient ground clearance. Okay, use maximum track overall width allowed, and use right frequency for designing spring stiffness. First you calculate, then you optimize it. Design to provide tunable features. Yes. As I already told you can adjust camber, caster, toe, damping forces, shock absorber for your optimum vehicle performance. Now SLA suspension. Now you need to select. So first of all, select which type you will use. There are many types. It is like friction stir, double wishbone, short long arm. This is double wishbone. Then trailing arm. See, each one have their advantages and their disadvantages. But some advantages would, the advantages and disadvantages would be specific to the vehicle category and weight. If I am designing a lighter vehicle, I can select something else. For a heavier vehicle, something else. For race car, that would be separate. For general road cars, it would be separate. So, what are the advantages of double wishbone suspension? Lightest weight, lowest unspun mass, greatest adjustability for roll center height, camber, caster, etc. You can adjust for it. Then spring on lower arm. Yes, here. Here there one more parameter where you will mount the spring and damper. This is also having some features. If you mount it on lower arm, when you speed up on your vehicle, or if you are hitting a bump in bounce motion, the camber will try to push upper joint to the inward of the vehicle. In that case, you have to strengthen the top portion of the tie rod, where you are making connection of your knuckle, connection with the vehicle. And if you are mounting it to the top upper arm, then in your bounce the motion will be okay. But when you will be cornering, there are problems, because the lower point would have the maximum forces. So this will affect again oversteer, understeer, which I will come later. What is oversteer, understeer? So here in this layout, ball joint is subjected to pull out load. This can open out the ball joint. Why? Because upper portion will subject to the inward load, and the ball joint is at the bottom. So that will, the maximum forces would be acting on ball joint outwards, and it will try to pull out. Now spring on upper arm, the opposite to that. In this layout, ball joint is subjected to push load. Yes, here the forces would be acting inward. This is better design and ball joint can take higher loads. However, the space required is higher, yes. But there is one more disadvantage which is in corner. I will come to this. Now, trailing, see, this is the very critical suspension load and very good also. If you can design it correctly, trailing arm. The earlier one, the main difference is here the both the wheels planes can be different. But in earlier suspension design, it is independent, but the wheels are in same plane while motion. Their planes will not be different. But here it could be different also. So suppose I presented you one rock hurdle. So for that rock, this trailing arm would be very good suspension. Because there is one time one wheel will be somewhere else and another wheel will be somewhere else. The planes would be different. Your roll motion would be restricted. Vehicle will not try to roll. And bounce force will also be not acting in uniform manner. So the overall torque movement on the roll movement would be nullified. But designing this suspension is very critical. See, construction is very simple. Even by visualizing, you can say it is very, but on the real ground, it is very difficult. Why? Because when you are taking a cornering or a turn, there are lateral forces. So, as I said, you for a linear motion, bounce and roll would be restricted, no problem. But while going laterally, or any you are suppose taking a high speed turn, then maximum force will come in lateral direction. To negotiate that lateral force, this trailing arm shall be restricted completely. Because what happens, the complete trailing arm moves away from the vehicle. In that condition, the vehicle, your motion will take into account, and you can break your not only suspension but steering part. So here now I am not going to tell you how you can design it, but yes, please study as much as possible if you are taking this suspension into consideration. And yes, implement it. And, it is suggested to implement it on rear axle. Now, if I go through this minimal package square sugar, wheel masses are independent of one another, wheel planes are independent, right move improves. Now, this have one poor roll stability. This in cornering, poor straight line driving stability. This when you are not straight line, you can choose with restricted suspension. Roll cage height, yes, here roll cage height is 0. Roll center height, sorry. Unless special measures are taken, lateral loading, which I mentioned, results in oversteer causing elastokinematic wheel fiber. Because oversteer will happen in lateral. Driver will try to control the vehicle, but still with in effect of your motion, your movement, the vehicle will be trying to rotate. So straight line, okay, no problem. That you can control easily. But lateral motion, it will be difficult. Motion ratio and spring stiffness. See, this is you need to calculate for each, and you will be knowing all the parameters of your suspension. What is the dia of your coil spring? What is the coil dia and what is the spring dia? D and capital D. Then what is your A and B? A means your arm length. Then B center from tire to the this one length. So this A by B is your motion ratio. Now again motion ratio is critical parameter. You cannot make it large. So try to keep this motion ratio near to 1, not more than that. because this will again increase your vehicle roll movement if you will keep on increasing it. Fog socks. Yes, see some teams will use these also. These are already very popular in BAJA. You will just buy it from the market, but you please check the parameters and try to fix the force correctly because it is adjustable. Then suspension compact detail, component details. You already know what are the components. Spring would be there, damper, upper arm, lower arm, linkages, bracket, arm, eye dimensions. These you need to calculate, and yes, then you need to select some components also which you are not fabricating, like kingpin. So whether that is uh, taking the load because there are variety of materials available in the market. Because major kingpin, there are some certain components I will tell you which you need to keep in extra while you will be at BAJA side as spare parts because failures could be occur in that component only mostly. Effective suspension geometry on handling of vehicle. Like see, I told you, no, there are if you change one parameters, the vehicle's other parameters will suffer. Like suspension adjustment, when you will do it, front spring rate increase, you just increase the spring rate, adjust it. You then more understeer, then symptom of too much adjustment, terminal understeer, front of car hooks in corners. Because understeer will happen, the load will be acting on the front axle, the side which you have adjusted, and that will pull out the you will try to turn it at the turns, but steering will not be effective. So it will be going into understeer. Front spring rate decrease, again same oversteers, less understeer. So these are the parameters. You need to study. See, everything is there in the books, in your course also. But this is just an example. It's just selecting the components from the market and fitting in vehicle is not the design. First, you please do the calculations carefully. And synchronization will work with other systems who are affecting the performance, like suspension and steering teams should closely work together. Then, if I say toe, there are many parameters. Toe in front, if you stable it, means adjust it. Effect on vehicle handling limit adjustment, car is stable while going straight. Turn in is average. Symptom of too much adjustment, car has slow business, under braking, feels out, wears out, outrage of tires. Toe in, rear. But toe is also how you are adjusting, whether it is toe out or toe in. So for general cars, it is on the road, it is slightly toe in. For your race cars, toe in will not work, may not work correctly. So you need not to compare with the already designed vehicle models because that is the application is different. So टो इन से क्या फर्क पड़ रहा है, टो आउट से क्या फर्क पड़ रहा है, बट ये टो इन टो आउट अकेला it will not be affecting your vehicle. With टो इन, what is the camber adjustment? What is the caster adjustment? So caster, camber, toe, all three would work all together. If I am changing any one, the second parameter and the third parameter will also change. So whether that is for your, it is profiting you or you are going into loss with that adjustment. Now requirement of the steering system. So why see again suspension and steering, as I told you, two are integral. You need to design all together. Again, now with suspension, steering arm is there, and the pivot point of double A arms and your tie rod, it will be nearby. So whether if you are hitting a bump or your vehicle going into air, so whether that tie rod is having free motion or it is hitting your upper arm or lower arm in full travel, that please check whether it is traveling freely or not. Must provide control over the direction of travel. Yes, we know steering's purpose. Good maneuverability for parking the vehicle. Smooth recovery from turns as the driver releases the steering wheel. Minimum transmission of road shocks from the road surface and road wheel feedback. Now steering topics, steering system, steering wheel geometry, understeer, oversteer, Ackermann, turning cycle, this we will discuss. Driver, this is the operation. You already know what happens when we turn the steering and which part will be, which wheel will be turning. Now here two, three most critical parameter will come, like steering, ratio, and other things. I will come to that. Wheel geometry of tire. See, we were not focusing, we are not taking consideration in tire and wheel when we were discussing the suspension. We were restricted up to spring, temper, A arms, but now with steering, this wheel also would be coming into picture. So here you see, okay, if you lower one point, if you see, that is your steering point, and other parameters are also linked to the wheel. So in the wheel plane, uniformity shall be there. Suppose if you are making this pivot point of double A arm suspension to the wheel knuckle, make sure you are following the wheel plane. If there would be slight offset, the lateral load will affect and your knuckle will be destroyed. Because knuckle is also a critical point where all the force all together will work on the knuckle only. So knuckle there would be, how many linkages would be? Steering arm would be pulling it. Then your upper arm and lower arm, they would be subjecting that into load. And your wheel motion also, wheel load from the bottom. So first of all, design the knuckle correctly, then you make the points for the suspension. Then where would be my arms falling and where I should plan the steering arm. Now we will come to steering arm. Steering arm, see, you can plan either front also or rear also, depending on your vehicle stability and design. You can make it. I will come to Ackermann steering where you will understand what is front and what is rear. But generally, when I say with respect to wheel plane, in the direction of travel, front and rear will locate. But when I see top to bottom, it is not planned generally at top of the vehicle. The steering arm would be mounted or designed at the bottom, this lower side of the knuckle. Because most friction force on the tires, where it will act on the tire contact side. You need to negotiate that force actually while turning your wheel. So if you will put this at lower end, so the torque would be less applied. If you will take this distance upper on the wheel travel, wheel plane, you can see someone has designed here. He could have designed here also. But force is acting at the bottom at contact edge, so the distance is less. Torque would be less. Effort would be reduced. And you have limited steering effort in your design. You cannot design a steering wheel like where you are the driver is applying more torque and he has fatigue, he cannot travel 4 rounds of endurance. So driver fatigue you need to also need to consider. How if effort is lower, this means this is the best point. But that in that plane also where I should AI. So you see two parameters are there, scrub radius. Now this scrub radius, if you see the right picture, the kingpin inclination and the tire contact center of the tire contact wedge. When the kingpin inclination is going out of, see, vehicles, driver is in inner right side. So this scrub radius is positive. And if the kingpin inclination is happening at the same point as tire contact patch, then it is zero scrub radius. And if this kingpin inclination hitting the ground before the tire contact patch, then it is negative. Now, yes, this could be positive or negative, no problem. Because if you bring this kingpin top axis or this swivel axis to if you will plan it nearer to the wheel and in vertical direction, then it will be 0 or minus also. But if you will separate it from the wheel, means you are making it curve, you are leaning it towards the vehicle, the kingpin inclination axis, then your steering radius scrub radius would be positive. But generally try to keep it positive. Why? Because your BAJA vehicles, you have tires fixed. You don't use, I think, for flat tires there. Your tires would be curved. So for curved tires, already this if you are giving it negative, means you are taking inner side. This means you are adding a force which will try to camber in, which is not suitable to you. And your tire wear will happen for long run. But anyway, you can make it negative or positive, but don't take it. The value should not go more than 1. The limits are there already. But scrub radius shall not be more than 1 in any case. Or from the wheel tire, it should not be wheel's width. You restrict up to wheel width only. Make sure it is not going in positive or negative out of the wheel. This means it should not come here or here. It should be within the wheel plane only, wheel width. Now, kingpin inclination, the axis which is coming. When you connect the tie rod of the steering with steering arm at the knuckle, the connection point where you are connecting the kingpin tie rod end to that point, it is not perfect that. Just some people design, some equipment design, what they will do, they will complain, they will put it. Analyze it carefully that steering arm connecting hole, it will have a plane which is not horizontal. And the degree of that will decide the kingpin axis. So if that would be horizontal, your axis would be out of the tire. So there would be slight angle in that. You can, if for this, you can check the available means general car also which are running on the road. So you can check the kingpin point steering arm in that. It is very critical to design it. Because here the caster also will play a role. So caster angle and steering arm, this kingpin axis, these things would be not in horizontal plane, and don't keep it in horizontal. Now kingpin inclination, as I said you, angle between the swivel pin axis and the vertical. It is inclined with the vertical. And scrub radius is between the center of tire contact patch and intersection of the swivel pin axis and the ground plane. Now tie rods. I will tell you my experience. I participated in 2009 in BAJA. I designed suspension steering system for my vehicle. See, in design phase, we will see we some at some point we will be overconfident. Yeah, some हो गया आपको जरूरत नहीं है. That shall not happen. Because why I was confident at that moment, I designed the vehicle and I calculated the tie rod length. I had some length, X meter, X mm. Then I searched the market whether any already available vehicle having this length tie rod. Yes, I was very happy. One vehicle I found that tie rod. And instead of manufacturing that tie rod by our own, I went to the market, I bought that tie rod and fixed that in that vehicle. What happened? That was not for race car. My vehicle was for race car. The durability was parameter was not there in variable loadings. Yes, in normal road driving that was tested. That was not for off-road vehicle. So that was not for off-road vehicles. What happened? We completed every event in endurance, 3 laps our vehicle took, and in 4th lap the tire took. At that time, the spare parts we never thought we should take some carry some spare parts also. So we from that stage we the fourth run our vehicle was out actually because of that tire. Otherwise everything was fine. So you see everything is available in open market. I told you already. First you design by yourself. You can keep them spares. So these are critical part where the continuous forces are acting. On tie rod, your lateral, this vertical, longitudinal, and torsional. Three forces, one moment continuously will acting on your pin, the second end of the tie rod. That is the critical parameter you need. You take care of while designing the length of the tie rod, which material you should use it, the threadings. Obviously, you need to match with kingpin, but the whether it is hollow, what is the thickness. So you take into consideration whether I am designing correct or not. So that tie rod second end with kingpin would be connected to your steering arm, and that will be effectively turning your steering. And in durability, if you are running it, already you will validate your vehicle after designing and fabric means manufacturing. So you check whether performance is there because you would have a lot of time for that. Then again now camber wheel geometry, camber angle, caster angle. Now what is camber angle and toe angle? Toe we will come later. Camber is your vehicle is standing on the ground and if your wheel is projecting vertically in the top vertical plane, then it is zero camber. And if it is deflecting plus minus in the vertical, if it is inner side, then it is negative. If it is outside, then it is positive camber. Now this camber is also having many roles. So here you need to when you will come to your now I will come to that point I mentioned where you need to adjust your suspension. See, before after your static you will go to dynamic events. In dynamic events there would be different hurdles. It will not in a row. First you have to cross, you will have options also whether you want to go or not. But you can go to this event also, this event also, that event also. And at the last you will be going in the endurance one. So for endurance, your suspension select different parameters, and for dynamic events, you should adjust different parameters. Like I will tell you, suppose I projected one picture with rocks. If you are going to cross that hurdle, in that case, you can put your camber positive. Why? Because while we will hit these rocks, two forces will act. Generally, one obviously bounce force, which will try to push the vehicle in the air, and other is your lateral. It could be negative also and positive also. So lateral is not a problem. Problem when it will be problem when you are restricted, but you will have much spell over there. But here the main problem would be your bounce force, because that will be acting upward. And if you will keep your camber as negative, already the wheels are aligned, top point of the wheel is aligned towards the vehicle. So that force will again put a moment on that, and your knuckle will come out. This wheel will come out of the axis, because the bottom force will act in vertical direction at the lower point of the tire, which is already aligned towards the vehicle, and that will make a torque, and your wheel will be rotated completely. So these things you could take into consideration. Like here also caster angle, your inclination of the swivel pin axis projected into 4.5 plane through the wheel center. Here this picture is wrong. Actually the first one is positive and the second is negative. If the vehicle is traveling toward, in X direction. If it is traveling in Y direction, then it is okay. Desirable targets for wheel geometry. Now I already told you these are the parameters which you need to take into consideration. Wheel geometry for tire, toe out, toe in, already you understood. As I told you, the camber in which we were taking the vertical plane into consideration. Here we will take vehicles. Difference between the front and rear distance is separate the center plane of the pair of the wheel. If they are separating apart from the front, that is toe out. And if they are coming down towards each other, that is toe in. Tires you will already select it, so use tire size 22" or more, or you check what are the limits you have. Within that you can select the tire from the market. Desirables for BAJA vehicle, steering gear ratio 5 to 12. These are, everything is there, the limits in your rule book. Ackermann geometry, yes, you study that this whether you want to design as per Ackermann geometry. But for race cars, you put either parallel or reverse. So the middle one would be more effective for you, because the first one is for general road cars. So if you go for reverse, but then you need to take other parameters into consideration also, which will lengthen your design. But you can select parallel. Then bump steering. This is another feature. When you hit the bump, I told you already in camber it works. And again, when the vehicle will come to the ground, whether your vehicle coming outward or inward, that is this is camber parameter. But whether toe is affecting in that bounce, that is going to steer. So whether the bump after coming rebound, my vehicle is coming, wheels are coming all together or going apart, that is going to steer. So near zero bump steer, yes, you can do it by selecting all the intersection point of your steering tie rod, upper and lower bar bump should come and intersect at one point. Then you can nullify this effect. So thank you very much. And if you have any queries, you can place it to. We are running short of time, sorry. So you can please, please raise this. Yeah, yeah. Please put your one queries to Baha Forum. We will reply it one by one. Thank you so much. Thank you for your patience. Now you can check the scores and let me know.
Thank you so much, sir. I would request Wasam sir to please give him the momentum. Kindly wait. Just a minute.